Good morning, class 8 students. I'm your mathematics teacher, and this is the part 2 video for the lesson exponents and power. Till now we have seen what are the exponents, how they are represented, how they are expanded. Okay, and in this video we are going to study about the laws of the exponents. Now let's start with the video. Laws of the exponents. There are various laws which you can apply on these kinds of exponents. Okay, so this a is a base over here and m is the exponent or the power of the base. If a base repeats again in multiplication with itself, but the power changes, see here the power previously was m but it has now changed to n. So you can keep the base same and add the powers, that is m plus n, that will become in addition. This is the first law of the exponents. So this is the product law where the base are in multiplication, but you have to remember that the base has to be same. In that case you can add the exponents. Okay, so this is 4 raised to the power minus 3 and in multiplication with 4 again, but the exponent has changed to minus 5. So you can see the 4 over here is same. So the base are same but the exponents change, and there is multiplication sign also. So this follows the identity number 1 or the law 1 of the exponents. That is, when the base is same but the exponents are different, you have to add both the exponents. So you can add minus 3 plus minus 5 and base has to be kept as it is. Okay, minus 3 and minus 5, this will get added up because both the signs are in negative, so it will become minus 8. Okay, and you can also represent, you can remove this minus sign from the exponent and you can take the reciprocal of the given number or the base, that is 1 by 4 raised to the power 8. Okay, so this is how you have to apply the law number 1. Now see the second law of division. When the base are same but the exponents are different over the base and the sign is in between of division. Now here it was multiplication and now here it is division. When the base are in division and are same but the exponents are different, you can keep the base same but just take the subtraction of both the exponents or powers of the same base. For an example, 4 raised to the power minus 3 is in division with 4 raised to the power minus 5. Here you can see the base are same, that is it is 4, but the exponents changes to from minus 3 and here it is minus 5. So it follows the law number 2 as the sign in between is of division. So you have to keep the base same and take the difference of both the exponents. So minus 3 and minus of minus 5. So minus minus over here it will become addition sign. Now they will get subtracted because the signs are different. So minus 3 and plus 5 will give you 2. The sign with the bigger number is positive 5. With 5 the sign is positive. So we will have the positive sign over here. So 4 raised to the power 2 means nothing but 4 into 4. That means the number is in multiplication with itself twice. So 4 into 4 is 16. Okay, see some other laws of exponents. The other law is a raised to the power m and n. So here the inner index is m and the outer index is n. Exponents are also called as the powers or index. So this is the inner index, inner power or the inner exponent for the base a, and n outside the bracket is the outer index or the outer exponent of the base a. So in that case you can remove the brackets of the base, and you can multiply both the exponents or index, the inner index multiplied with the outer index. So let's take an example, 3 raised to the power minus 2 and minus 4. Minus 2 is the inner index and minus 4 is the outer index. So you have to multiply both the numbers because it follows the third law, correct? So keeping the base same as 3, multiply the exponents, that is minus 2 and minus 4, and remove the bracket of the base. So minus minus it will become positive, and 2 fours is 8. So 3 raised to the power 8. Okay. So in multiplication, if both the signs are negative, it will give you positive only. It is not like addition where you have to see the big sign of the bigger number. Okay, here you have to just see that if both are in multiplication and both carry negative sign, it will become positive after multiplication. See the law number 4. A raised to the power m multiplied by b raised to the power m. So here the exponents or the indexes of the base are same, but the base is different. So this is the product only, but the base are different and the exponents are same. So in that case you can keep the exponent same and multiply both the given base. Okay, for an example, take 5 raised to the power minus 2 and 3 raised to the power minus 2. So here you can see the exponents are same, but which is minus 2, but 5 is multiplied with 3. So one of the base is 5 and the other base is 3. So in that case you have to take the minus 2 outside the bracket and multiply 5 with 3. You again multiply both the base and keep the exponent outside the bracket. So at the top, this is the law followed by this example, 5 into 3. Okay, 5 into 3 will become 15 and minus 2 is kept as it is. Now you can take the reciprocal of 15 as 1 by 15, and the sign of this negative sign of the exponent will go away and it will become positive, 1 by 15 raised to the power 2. Okay, let's see other laws. The another law is the division law, where a raised to the power m is in division with b raised to the power m. So you can see again the exponents are same, but the base is different. In that case you can divide the base, that is a divided by b, and you can keep again m. First you can divide a by b and you can keep the outside the bracket the exponents. In the case when the exponents of the numerator and the denominator are same, like in this example, the example is 3 divided by 9. So the bases are different, but the exponent is minus 3 for here also in the numerator and the denominator also. So this follows this kind of law, the law number 5. Here you can write it in this form: numerator divided by the denominator and outside the bracket exponent. So 3 by 9 and outside the bracket the exponent is minus 3. So this 3 and 9 can cancel and it will give you 1 by 3. Again you can see it is minus 3. So you can take the reciprocal of 1 by 3, which will become 3, and this sign will not be there. It will become positive. So 3 raised to the power 3. Again you know that 3 when has the exponent as 3, that means it has to be multiplied 3 times with itself. 3 multiplied by 3 multiplied by 3 will give you 27 as the answer. The last law is the easiest one. Any base having the power or index exponent as 0, the value would be 1 only. Anything, for an example, 345 raised to the power 0 will give you 1. Okay, that means it follows the law number 6. A raised to the power 0 is equal to 1. Here it can be possible that the number is negative or positive or in the fractions. See 54 by 23 or minus 6735. Any number or any fraction raised to the power with 0 is equal to, it is going to give you number 1 as the answer. Okay, these are some of the laws of the exponents, and you have to keep in mind that both a and b are not equal to 0, and these exponents can be 0, positive number, or negative number, that means the integers. So this is the product law where base are same, so you have to add the exponents. Here this is the quotient law in, or the division law, where the base are same, so you have to subtract the exponents. This is the power law where the base is 1 and there is 2 exponents for the same base. In that case you have to multiply the powers. Then is the 0 exponent. Anything to the power of 0 will give you 1. And then is the negative exponent, where if the power is in negative, you can take the reciprocal of that number and it will become positive. The power will become positive after taking the reciprocal of the given number. Okay, I hope you have understood all the laws of the exponents for the positive as well as the negative exponents. Okay, the positive exponents always show the larger distances, as I told you about the distance between the two heavenly bodies like earth and moon, or any other heavenly body, earth and sun. When the distance is very large, it is given by the positive exponents, but the smaller distances is measured by the negative exponents, like the measurement of an atom in nanometers or micrometers, so that thing is measured by the negative exponents. So exponents make it easier to represent the larger distances or larger numbers, as well as it becomes easy to represent the smaller numbers by only giving a sign of negative over here. So negative exponents represent smaller distances and positive exponents represent the larger distances. Okay, so I hope you have understood the video. Based on this video, please do some assignment questions. Use the laws of exponents to solve the following questions. We will continue the chapter in the next video. Till then, thank you.